Hi, Yogesh.
Hey Jacob, hey Dean, Tanya. Sorry about the wait. This is a new system, and I think I had to reset the room in a way that it doesn't ask for people to wait. So it's just one time thing. They changed the permissions around and the logins around. So the previous uh, meeting series was hosted as someone else. So that's why they changed. Hope it's not a big deal. How's everyone doing today?
Good. How are you doing?
Hey, Marco, I'm doing all right, man. Good to hear voice.
Uh,
All right. Drew, did you ever get a response from IT at OCP? Did they fix it for you or you're still helpless?
Still helpless. So I'm logged in as the new account, but
You're not a co-host yet?
no. So but
I
I,
think
I
for this one, I think because you're not the lead, it would be Rama that they would set as co-host.
I
Yeah,
asked about. They told me they were going to make me lead of it. I mean, like so I could or host.
co-host for this. Yeah, I was going to ask the same. So yeah, yeah.
But
But right now that's not done. Okay, no worries.
and it
That'll
took
happen.
days for my Google account, my OCP Google account to get email or something. So that was the hang up. I had the account, but couldn't see the Zoom stuff to start it. Anyway, it's fixed,
Oh,
sort of. It's halfway working.
yeah. Somewhere there is a default setting which says make a waiting room, and that's what I need to go change. But over to you while I fix this. Let's get rolling. Collect opens.
Sounds good. So, uh, Jacob, I don't know if we've met before. So, I think you're the main person. Although Benson, I'm not sure I've seen you either. So, do you all mind introducing yourselves?
Yeah, absolutely. No problem. Hi, Drew. Hi, everybody. My name is Jacob Wright. I'm new to OCP and exploring. This is my first meeting. Background of myself is I come from the translation layer between software and hardware and currently work inside of Meta's AI infrastructure. So I'm exploring OCP, all of the initiatives, and very interested
Oh.
in the work that's going on.
So, do you work with folks like Anil?
Uh, I'm not sure I've met that person yet.
Anil Agrawal?
Let me see.
Okay. Neil is he's at Meta and he is kind of a data center reliability person.
Oh, cool.
So
Yes, I would. I just haven't met him yet.
okay, yeah. It's a small group of like it's a this is a fairly small community.
Hmm.
So anyway, that it's great to get to know you. It's great. It's wonderful to add someone new to it.
Cool.
So
Thank you.
welcome. Um, and I'll try to fix mine. I'm from Microsoft, and usually I try to say that, like we put in parentheses, like Tanya did, so people know where we're from. But I just
So,
haven't figured
so
out how to fix that.
yeah. Hey, Jacob, welcome. So, if you don't mind asking me a little bit more, curious about what exactly do you mean when you say intersection of software and hardware? Is it like a um, can you tell us more just for education?
Yeah, definitely. Yeah. So I work directly on the PLM org, and I was hired to evaluate the systems. I don't, you all are probably aware of what PLM does, product lifecycle management for various parts, components, full rack systems, etc. And my job inside of this team in org is to look at the systems we're using and try to correlate real-time data of physical items. Could be heat, could be performance, could be end of life products to software analysis and benchmarking.
Cool. Yeah. So I'm interested in stuff like that too. I think all of the fleet operators want to know when their fleet's wearing out, or if we're having some failure rate that is out of the expected range of failures for our part. So we're very interested in that. I think a lot of what we're doing now is geared at how do you tell an individual machine is broken or not, and how do you do the right thing for it? Uh, and we're trying to build a framework for that. But what I'm finding is the framework is gathering the data that you need for fleet level quality assessment. So you could do things like a Weibull analysis to say, hey, are my early life failures, in the range that I'd expect, or is there some sort of test escape that's driving it up? So we don't discuss that life cycle aspect too often here, but it is very relevant, and I think that the things that we're doing uh, support that. There may not always be explicitly in support of that, but I think that our goals are largely aligned. So it's really great to have you here.
Thank you. Yeah, I'm excited to be here.
Cool. And Benson, I'm not sure if I've met you or not. I'm so sorry. I'm spacing it today. Would you mind introducing yourself? Or maybe Benson, you're on mute if you're talking. Okay. Well, I'll assume that that Benson is unable to speak, and we'll get started. Okay. I just changed my name.
Before anyone asks, I did that. Before anyone asks, Manju is from Intel. He's a firmware guy. And Manju Harpanhali, we just call him Manju.
Awesome. Welcome, Manju.
It's good to have you, Manju. It's good to see you regularly here.
Thanks, Yogesh. Yeah, thanks, Drew.
Yeah. And for folks that don't know, Shibata is no longer with Intel. She's changed companies, and so she will not be representing Intel anymore in these discussions. Okay, I'm going to share so we've been working on air injection requirements. I don't, I'm still plugging along on the severity mapping. So the air severity mapping we were working on, and I have not uh, given up on that. So I'm going to paste that link and this document link in the chat. So that work is ongoing. I just have been focused on getting our RAS API work in order in the RAS API forum and within Microsoft. So, but there is progress on this, as I mentioned. Tanya, did some work for AMD GPUs, and we're waiting on NVIDIA to do something as well. Okay, and then I'll paste the hardware injection doc that we're working on also. And if you don't have access to it, let us know. In fact, what you may want to do, I'm not sure I'm seeing all the requests for access. So if you paste your name, so Jake, if you want to put your email address in, you can't get one of these docs, let me know. And Manju, same for you. And Yogesh and I can give you access to the doc. This is intended to be a group effort. We're trying to, agree to the terminology and use it consistently. So this week I've just did a little bit of cleanup, and so I don't know if we're going to stick with this particular picture or not, but this is something Seb drew, and it seems to match where we landed. So I redrew it as a Google Doc and I moved Seb's old drawing to the end. And I'm going to do the same thing with Anil's drawing probably after I check it. I think this was the one that was closest to where we landed. And for those of you that weren't here, we were having a debate about what was labeled what. And what I'd like to do is redraw these so that we can double click them and edit them in Google Docs. So I'm not trying to change anything here, really just trying to document it in a way that we can edit it and move forward. I also went through the air injection section, and I had added comments and others. I tried to clean up a whole bunch of this. I meant to accept that. So so I cleaned up a lot of the definitions that we worked on and that VLOS added. I I guess we need to talk about. I wanted to ask Dean about this. I usually think of machine check banks as error logging registers, and but I see how you're calling it error indicator. Error indicator to me is kind of like a bit that says I had an error, where the things that go into machine checks don't just indicate an error or an ARM error record, right? They contain data. So I don't know. I'm fine with changing the word logs because I see your point. But I'd like to have something more than indicators. Maybe error registers, error register contents or something,
Yeah, that
or
sounds fine. Yeah, I think logs is confusing because of the software implications that you've been using.
yeah.
Registers is fine with me. Um, yeah, I tend to be more abstract, so I think of indicators, but registers is fine.
Okay, if that's okay with you, I'm just going to do that. And I understood your problem with logs, so I wasn't pushing back. I just, worried about indicators. Just we have folks that I've seen some chips that just have a one hot array, like a 32-bit one hot array, and when a bit is lit in that array, that is your error record. And I think we want more. We want register contents. So cool. Okay, thanks, Dean. Um, Okay, I still have an action item here that I've not worked on. Um, and I don't, so what I tried to clean up was here. And I am happy for folks to review it. I mainly just accepted comments and accepted people's additions, and I deleted some things that I had added just in for clarification once it was clarified. So I didn't try to change anything, but if you all would take a look, what I'll do is we can move on, but I just invite you to take a look and make sure that I didn't screw anything up. Um, Okay, the other thing that I did was we've been talking about use cases and then tools used. And I'm not sure this table is right. But what I tried to do is I tried to take these use cases for error injection that we had discussed, just this kind of bullet list, and then some paths for how error injection might be done, and some of the environment and security discussions. And folks were trying to relate them to the use cases. So I made this table, and I don't know if it's right or not. This is extremely debatable. I'm just trying to align the use cases with things of interest. So I thought we need a description, whether or not you have direct hardware access, what's any security constraints for the injection, and then the tools used for injection. So if you don't like the columns, we can change them. This just seemed to be what we were discussing.
Hey, Joe, one request. Could
Sure.
we have like a column for, let's call it KPIs, if any expectations of, for example, latency or something like that?
Oh yeah.
Or first even like like outlining, does something like that exist, right? And then if
I don't. I mean, we talked about performance implications briefly, but
Mm,
these performance requirements are things I made up a couple of years ago when I started this talk. So it's like one person's 20 minutes of thought. So don't take it too serious.
um, yeah, well, that's a starting point, right? Like, I'm just saying it would be, I would love to see that column and then, jointly fill that in because
Okay, we may need to.
at least it internally helps me a lot when I'm pushing for things like saying,
Yeah.
hey, we need to actually look. Joe from Microsoft said this cannot take 5 weeks.
Okay. So uh like is there a common term we can use? I mean I
Like I don't
performance
know.
implications or
So a term I like, but it's just me. Sometimes we call it KEIs, key experience indicators. But so, which is then really the idea of, okay, this is what expect this to happen, right? For example, if you're doing an error, well, since we're talking about error injection, right? Um, you
Yeah.
probably want the error to, let's say you are doing your validation of your stack, you probably want the error to appear within a second. Of course, I made that number up, but something along those lines, right?
Yeah. Well, I think like
What's wrong with KPI, Marco? I mean, isn't KPI very
Yeah,
commonly used performance indicator? I mean, description says what
yeah,
experience you're looking for, the second column.
yeah. I mean, you can call it KPI as well. The
Yeah,
usually the way I've been delineating the two, I'm just going to use client language because that's the
but
easiest.
the experience is
Uh,
very subjective thing.
yeah, so
Performance is
let
more
me,
measurable
yeah, so
thing.
you guys bear
well,
with me for like 1 minute to explain you the difference in my head, right? So if you think, I'm just going to talk about a client device, right? There's an experience of my laptop runs on battery all day long. That's an experience, right? And the performance indicator behind that would be that I can be on a Zoom call at, 500 milliwatts of power on average, right? That's the difference, the delineation in my head. But I'm okay with key performance indicators.
I mean, I don't know that
So both the things that you let me respond to both the things that you mentioned is are basically performance indicator. Number one, you want
Mhm.
the battery to last a certain amount of time. Number
Mhm.
two, you want during the time programs that exert certain number of hardware elements at a certain clock speed. When you put it in experience terms, it's very vague.
Mhm. Yeah, and that's basically the difference. But we can use key performance indicators
let's just
as
see. I
far as
don't. I mean, I'm open to adding it. I'm not sure what we're going to put on it, but I mean, I think there's probably cases where we'll put things, but I'm not quite sure how it's going to be used. But let's try it and see what happens.
I think it'll be things like round trip time, things like um, response expectation, things like um, access to certain types of um, hardware. Those would be your performance KPIs, right?
Okay.
Is this
exactly.
something along the line of SME? Like
Sorry,
some,
could you say that again, Tanya? You broke up a little bit.
some sort of, is it along the line of SLA? Meaning we usually say,
Yeah, that's more broad though, right? Yeah.
But
Mm.
that's kind of what I think is going to end up getting there, because I don't think there are going to be non-functional requirements that are kind of like an SLA.
right, it's sounding more like along that line rather than KPI or KEI.
So let's think again for injection. What is really important?
Well, let's not sweat it. Let's just kind of keep it this
Uh,
column open for those.
let's think about it for a minute, if you can, right? What is really that we look for injection? I mean, all these things are overlapping. Experience, SLA, performance indicators, they're all overlapping, right?
Well, and
What?
reliability. Sometimes you inject an air and it doesn't inject.
Yeah. So that's part of your experience and service level. What, if anything, that we really want to? So, what was the purpose of this table in the first place, Joe?
You're really muffled, Yogesh. I couldn't make out that last sentence.
What was the purpose of this table in the first place? I'm just trying to see why we're doing what we're doing in this column.
To align the different sections of the document, because this is, if you remember, last week we agreed that we wanted this table, and
Mhm.
I'm not sure the format's right, but the
Mhm.
goal was to align the other sections of the document with the use cases. And so people said, what do you use in each use case? We need to organize this by use case, put a table in with the use cases. So Ergo, here's a table with use cases. Um, I think we should go through it and see if there's anything to column, but I don't think we should get this perfect. Let's just move on.
No, I think thanks for that explanation. And I think with that, all of the above is a true answer, really. It's performance indicator, experience, or SLA, any other expectation. Let's put a placeholder for the last in the last column for all of those. And I think answers will vary by the line item. So let's go with that.
Yeah, I mean, I just don't overthink it. Yeah, let's put whatever we put there, and and it'll work out. And Marco, I'm open to it. I'm not pushing back at all. Let's see what happens. And what we may find is that there's a theme in that column, and we'll rename the column to match the theme. That's fine. So
Exactly, that's perfect, right? It's basically measurable things, right?
okay,
That's
yeah,
all.
yeah. So what I'd like to do is move on if we could, and uh, and so if we want to, if folks want to add something, then add it. As I said, I have no objection. But these are the use cases I had mentioned before, and we had talked about pre-hardware emulation, lab testing, production environment, but not running customer workloads, uh, uh, testing data center automation, and debugging and reproducing issues. And I'll try to make this. I wish I could. Oh, that actually worked. I wish I could flip this one table's pages to landscape. I'll see if I can do that with Google Docs or not. Um, but these were the use cases that we had listed in the doc. I don't even know if they're right, but they seem like a pretty good starting point. And then like in pre-hardware emulation, uh, you're doing things, you're developing stuff before the hardware is available. You sort of have, didn't know what to put for hardware access. You sort of have access to hardware in that you have emulated hardware that you can monkey with, but it's not real hardware. So I just put yes, but emulated. And there are no security constraints. There's no customer workload. There's no this is emulation, so we can do whatever. Um, and the tools are simulators and representative error logs for spoofing, and you probably are developing error analyzers at this time. And so that's my guess. That's my thinking about what's used there. Uh, and then we can just go through though. Do you see kind of what I did with this table? And I love feedback, so don't hold back.
Yeah, I mean, the only thing is only input I have by hardware access. Um, I'm wondering if it is really a yes or no, or if it is you should qualify it more into, I don't know, local hardware access, remote hardware access, emulated, because there is no real hardware. Yeah.
I mean, well, I think the when we say hardware access, I mean physical.
Okay. Physical hardware access. Okay.
Yeah, like you can plug stuff into it. So, I mean, like in production, sure, we have access to the hardware through software, through management interfaces, but a lot of times when we deploy servers at scale, we might remove JTAG headers, right? They're just gone. So you could have a problem, and if you want to plug, a JTAG debug device in, well, sorry, the header's gone. Now, the BMC might have it. We do. There has been a lot of work for debug at scale, and so those tools obviously apply for production environments.
But you may have locked that too for some security reason, right?
Oh, absolutely. Yeah. And we talk about, that's and I'm pretty explicit here that, in the security section, we talk about unlocking and unlocking, and that debug is separate from error injection. It's just a different thing. And we're talking about error injection here, so that's the only reason I mentioned debug is that it's independent of error injection. We're not wrapping the two things up. That's the only reason I mentioned debug at all in this row. And then there is a debugging, error injection is used. I mean, I think Anil pointed that out a while back. And I've done it too. I've used error injection to triage and debug problems in the data center. So, I talk a little bit about that. But why don't we go through this a little bit, and I'll take feedback from folks. Um, and welcome you jumping in the dock and adding comments and questions or just speak up. So let's look at the lab testing row, and it's kind of split because of a page break right here. So that's why there's a double line. With lab testing, we're talking typically it's pre-MPI deployment, and it
What's
might be
what's NPI?
a new product introduction. It's defined earlier or it's defined elsewhere in the doc.
Okay,
So
thanks.
yeah, and NPI is usually at a hyperscaler. We have some process for getting early hardware and testing it, and then building EBT, DBT, PBT, and at some point we think it's good enough to go GA and be deployed widely in our fleet. And so there's some process for kind of testing and proving to all the stakeholders that everything's working as they expect it to. And you have to jump through hoops in the MPI process uh, to ensure that you're deploying something that is good. So lab testing is usually like the beginning of, like the MPI process starts in the lab with prototype hardware. But sometimes, we're just, we come back to these lab machines too if we have a problem. So like I mentioned down in debug, you might go back to the lab environment for debug, especially if you can reproduce it. Because you have more flexibility in lab. You can touch the hardware. You can hook up wires or oscilloscopes or PCIe analyzers, and you can't really do that in most data centers. So in the lab you have full access to hardware. There are no real security constraints. It's lab, so we're not worried about customer data. It's all a complete test environment. It's exclusively for testing. And we use lab instrumentation, air injection hardware, magic known bad parts that we understand the failure in, JTAG interfaces, and then things like ACPI, EI&J, or in the future maybe CPAD-driven air injection might also play a role. So, within error analyzers, error analyzers is pretty much everywhere, and this is actually kind of an important point with this, that error analyzers, once we have them and we have the kind of flow from the hardware somewhat standardized, this is going to supercharge some of our early testing. Because now what happens is we get an error, we have no idea what it is, and we spend a few days every time we see something new scratching our head and trying to figure out where it happened. And if there's an analyzer that says, yeah, this is a flaky CPU, and I send it to the supplier with all the details in the error log, and they go, oh yeah, send that part back. That's a weird part. That'll speed things up rather than us scratching our heads every time we see something unexpected. And also, we have a lot of people in this time period in the lab that are not necessarily error handling people. And those error handling people are seeing weird hardware errors because the system's not configured correctly, or maybe we don't have memory training quite nailed yet, or maybe the boards are a little bit flaky because they've been mishandled in the lab. That happens fairly frequently. And so having an error analyzer say, yeah, you should probably check your DIMM slot. There's something, it looks like all the ranks in this slot are bad. That would be super helpful in the lab. Okay. From the lab, we go to a production environment, but not running customer workloads. When I say environment, I mean in the data center, where we can use our data center control plane and all the associated tools with it. But we're not running customer workloads. We're just proving that the new product that we're introducing to our fleet works with the tooling that we use to manage our fleet. So if there's a failure, we're sure that we can recognize it and help the affected customers move to another machine, and that we can repair the machine. Things like that. That's the kind of thing we're doing. And so, we're testing interactions with the control plane. We'll have a stack that will be deployed, and so that's what we want to test. So, we want to be, and it's not that we're always running that stack, but it's usually a prerequisite to NPI that we say, hey, I've got a firmware image, I've got an OS image, I've got a BMC image, I've got management software, I've tested them. This recipe works. We can deploy with this recipe. And then, if you go muck with it, like you change firmware, then we redo some testing, confirm that firmware is good, and we have a new updated kind of recipe for that we roll out to our data center. And then sometimes, the different versions of the control plane might interact with different versions of firmware. We have to test all of that here. And so, that's why I talk about, we need to test the stack that will be deployed. We're confirming that error logging and fault handling features work as expected in this environment. And this is testing at larger scale. And so, I've heard the term air miles. I don't know if there's a better term, but basically, the more hours you have of operation with the machine, the more chances you have to uncover problems with the machine. So, testing at scale kind of helps bring out problems that might have been missed when you only have a handful of machines in the lab. And this production testing I'm talking about may be part of an NPI. It may be that we're getting ready to release a new product. It might be that we're just rolling out a new version of firmware or new OS or something. And so in those cases, we need to do that testing too. And that's not we might inject errors in all of these, in both NPIs and just rolling out new software. And it's typically disabled by default of production error injection, that is. And we would explicitly enable it for this testing. And we want it disabled for customer workloads to prevent denial of service, among other things. And I don't know how to put it. I was saying error injection enablement is measurable. We need to just be able to see whether error injection is enabled or not. We need to be able to survey a machine and say, is error injection enabled? And if it is, then we're going to maybe declare that machine untrustworthy. But we want security features to work for the error injection testing, because we may have we're typically going to deploy the security features to our customers. They're going to use them. And if the machine fails with those security features enabled, and we're unable to diagnose the failure or unable to drive a RAS action as a result of a security feature, we've got a problem, right? We're doing a big disservice to our customers. So, error logging and error handling features are expected to coexist with security features, and we'll test that in this environment. And then I just mentioned debug features are controlled separately from error injection. It's just a different thing. So that's all I'm trying to call out. So any comments so far? I mean, is this shocking to anyone? I mean, I think we've discussed this stuff. I'm trying to summarize it in the table, but it may surprise some of you. Okay. Well, I welcome feedback. Go ahead, Marco. Thank you.
So I mean, enabling is actually the question. So I'm guessing, I guess the thing that you've used, I'm guessing that the enabling and disabling of error injection needs to be secured, right? Is that a fair assumption? And who should be holding the key to that securing? Would that be Microsoft in your example? Probably,
I think
you're going to do this a lot. I would guess, right?
Yeah. I mean, generally that's right. Like the server fleet operator is responsible for the behavior of their fleet and the configuration of their fleet, and so error injection is one of many aspects that a server fleet operator would configure. Yeah. So that's I can add that. Enablement.
Hey, Drew, this is Anil. On the first sentence, the error injection is disabled by default in production. I think maybe the right way to put that is enabling, disabling error injection capability is hyperscalers policy.
Say that again. I was typing and I kind of missed what's hyperscalers policy. I'm fine changing. I just didn't quite follow you.
Yeah, so this statement may not be true for all the hyperscalers. And error injection capability, we, depending upon the error type, we may keep it enabled in production.
Okay, so maybe I'll say may be disabled by default in production.
No, it's a hyperscale policy, right? So we want to clarify that this is a CSP policy.
But Anil, would you still want the change of state still be in a secured way, or if it's enabled by default, you don't care?
So security concept in our domain, right, has a so root of trust, the way we define, right? Because the error injection by default requires ring 0 access, and so there is no direct, I would say, security impact here. Because if somebody can get into the root, then they can do a lot of stuff. So we secure it in different ways. From an error injection point of view, there's no new security measurement. No measure.
And that's that's from a perspective where you're not a cloud service provider, right? You're running your own workloads, and I think that's legitimate for you, right? Right. And then Microsoft is different. We might give someone a machine that they completely own, that where they have root access. It is conceivable, right? Or like we may have a bare metal machine like that, or more commonly, our customers run in a virtual machine environment. So we would have different requirements from you, and our requirements around error injection would probably be stricter, in terms of how it's controlled. Because I don't want to cut.
Yeah, +1 to true. Yeah, and this is discussed well in the GPU RAS work stream, and there is a 2 solutions. Silicon vendors also approved. Okay, yeah, we can refer to some of that.
Yeah, I wasn't talking about techniques here. I'm talking about requirements, but I agree. Leverage the techniques listed there. But like if someone had root access and could enable error injection, then they could make us replace a whole bunch of hardware, and that's not really good for us. So we would like them not to crash their hardware and blame the hardware. So we would typically disable it. And then we can massage this too. But I just said it's based on server fleet policy, operator policies, and but Anil, that document, the disabled by default was from the GPU RAS spec that we agreed to. So
yeah, I did not agree with that. So that's a different topic to discuss.
Okay. I wasn't making that up. I did get that from an agreement. Okay. So, and then the tools here, software-driven error injection tools like ACPI or CPADS, debugs at scale tools like a BMC-driven JTAG. There may be other vendor-specific tools that do not require additional hardware, and I'm not sure how to say that, but my point is we're not going to go into these data centers and plug something into the machine. Typically, those headers have been removed in many cases, and then we have workloads, and we'll have special workloads that stress the system, and then we'll have workloads that are similar to customer workloads and error analyzers. And so I may have missed some tools here, but this is, what I saw in the doc and what I think we've talked about. Okay, and then the next is testing data center automation, and we have a helpful page break again. So I apologize, but it's all this. So I apologize for that. And so with testing data center automation, we're validating error analyzers and RAS actions and CPAD policies, and like we'll have dashboards we use to watch the fleet and see how healthy it is or unhealthy it is. And the hardware errors that we're talking about, the hardware error logs may originate from silicon or from a higher place in the control plane, not place. This could be spoofing. And in this case, security is managed by the fleet operator, especially in cases where actually security, if it's done in the machine, is the same as above, right? The machine is locked, unlocked. But if we're injecting errors in our control plane pipelines, then it's the server fleet operator's problem to secure their control plane pipeline. And then the tools would be similar, to what we do in the data center. And if I'm injecting spoofing in the pipeline, then the server fleet operator has to do that spoofing.
In this
Oh,
one,
go ahead.
you probably have some like latency expectation, right? That would go into that KPI.
Yeah. Well, but the latency expectation may be the same as here, though, right? The production environment.
Yeah. I'm just thinking, like, if I'm testing something, right? I have I have pass and fail criteria, right? And if it's unknown how fast the error occurs, then I don't know if I'm waiting for it because the injection was slow or because there's a bug in my reporting stack, and that's causing the problem. So that's what I'm thinking.
That's right. And like I encourage people to timestamp. I mean, so like CPRs have timestamps in them, so that'll help. But then, I encourage you timestamp things in your control plane pipelines so that you can find your bottlenecks. I mean, but that's no secret. That's just like, common at scale data center practice.
But what Marco's pointing out also sounds like it might be a different requirement. That is, how do you know that the injection is actually in the machine or in the target location, and does it wait to trigger an access by some other action or by time or randomly?
Yeah.
Those might be requirements that you want to talk about when you talk about each of the different methods as opposed to a use case.
Yeah.
You hit it on the head, right? It's like a certain level of predictability, right? If the error is going to be there after 9 milliseconds, right?
Yeah.
And if I'm assuming of course I'm making up numbers, right? If the expectation of your stack is that it reports it in another 10 milliseconds, if the answer isn't there after 20 milliseconds, you sort of have a bug.
Okay, I'm taking notes in this column for the moment, and then I'll try to work those. Yeah, your point is perfectly well taken. You are right on. But I'm just going to take notes in the column for the moment, and then we'll try to clean it up. I just don't want to lose the thoughts that are coming out here. Thank you, Dean, for making sure I understood. Dean is a Druid whisperer sometimes.
I mean, for me, it's not about time, so I'm a little surprised that you'd want time, but time might be an interesting factor. For me, it's also about the interface, right? The interface tells you. I mean, I think there's some. I remember a trigger option, and I think it was particular to Intel. So it's about predictability, right? Is that the word Marco used?
Yeah, and that's what Marco said, right?
Predictability, yeah, exactly. It's about predictability, and there's different ways to do that.
Exactly, the time is not, I think, not so much about, it's got to be as fast as possible. It is about, it's in a predictable time, so I know how long to wait for it, or I can set then a deadline to my actual test that says, the error should have been reported within, I don't know, 10 seconds of being injected, based on maybe unexpected behavior.
Yeah, or error injection. There's like you can configure the error injection. and then you can trigger it, right? Uh, and so that's part of the predictability, and it's pretty simple. Sometimes, and this is not necessarily just an Intel thing. I've seen it in all sorts of chipsets where you say on the next transaction of this type with some
Yeah.
sort of matching, trigger the error, and so you have to
See,
have that transaction for the error to occur.
the two things, right? There's latency to initiation if it requires a trigger, unless you give the transaction of the nature that's required to cause that, then it will not happen. Second is the the round trip time, right? Your injected bits have made it to the target, and then you are waiting for a confirmation or result acknowledgement of some sort. It may or may not have result of what happened. So there is that. So there is an initial trigger, means if there is a trigger required, then it should be, of course, part of the documentation explicit that this is how you do it.
And like in some distant future, I could see us saying, well, maybe what we want to do is I'll have some sort of log that says an error has been configured to occur, and we are now waiting on the trigger. And that way, when the error was configured. And if the trigger never occurs, then the problem is with the triggering and not the setting the system up for the error. Or maybe there is something wrong with the way you set it up, and the thing you thought was triggering it didn't trigger it. But I think there are two times, right? There's when you set the error up, and then there's when you triggered it. And for some errors, it'd be the same thing, right? Like triggering and inject, it's all one event. And for some errors, it's two things. Go ahead, Anil.
Yeah. So in the EINJ implementation, what Dean was mentioning, right? There is no trigger field. That is used to distinguish between where you're implanting only, or you're implanting and then triggering also. Right. So that's a kind of requirement. I think it's good to call that out, even though EINJ already support that capability. But if somebody is building some other error injection solution, this requirement will be useful to clarify that we need a distinct capability to implant and trigger.
Actually, sorry, I may have been distracted. What exactly is meant by implantation?
Yeah. So for example, if you take an example of memory, right? So if you want to flip a bit, you need to do write, correct? And then if you want to detect the error, you need to do read.
Right.
Right. So you can implant error by simply writing different addresses, but don't do any reads.
Yeah, you don't see the error. Yeah.
Exactly. Right. So you implanted a bunch of errors, basically kind of pattern that you want to do, and then you say, okay, now trigger. Then that means you're going to read. So we need that distinction here. In fact, I developed a solution for poison handling flow testing using this capability in the EINJ. And it was very effective because that's the only way you could do that.
I've done that too. And like one thing we may want, like something I've been asking for from lots of people is it's really difficult with poison testing to test PCI and poison because you got to inject an error typically in memory, and then you've got to do it in just the right place for the driver to try to pass that
exactly
to the device. And so in my dreams, I would solve that problem along the lines you're talking about, Anil. And I was talking to Antmicro about doing this actually, because they were going to build a kind of a PCIe error injector tool that went into in the middle of the link. But what I'd love to see is the ability to implant a poison injection in PCIe. And what I'm saying is when you see a next transaction of a certain transaction type or a certain PCIe address, BDF and address on that device, then turn that TLP into a PTLP. And
Yeah.
then we don't have to inject the memory, and it's a lot easier to ensure the driver is going to use it.
Right. The Poisson flow or the PCIe, right? We also use a similar approach that we use EINJ to implant the error in the memory, an address which is accessible, let's say, by a device or some driver, right?
Yeah.
And then we do a transaction from a device to actually do a memory read. And that memory read actually then detect the error, and then the Poisson data flows through the PCI hierarchy to the device, and Poisson TLP is detected. So
Right.
that's another use case.
Yeah, and if we could simplify that to say, hey, when you see this, address, PCIe interface, or maybe it could even be the next MMIO access, turn it into a PTLP, or the next, a PIO. You could just even say, poison the particular PCIe transaction type.
Yeah, I mean, yeah. So just to summarize, right? We just, from a requirement point of view, we should clarify here that we need a distinct capability to implant and trigger. That's a requirement.
I don't think that fits in this table. I agree with you, but I think it goes somewhere else because it's universal. You know what I'm saying? Like it applies to all error injection and fault injection.
Correct. It should be something like a common requirement, right? I want to call out one more thing. I think you were touching earlier the error logs. So we need a distinct capability in the CPER log, which actually already exists. It's just people don't use it very effectively. If the error was created, if the CPER log is created as a result of injection versus a real error. And CPER format, if you look at the header, I think we were talking some time ago, Vilas pointed out, in the header, there is a bit already defined, that if you set, then when somebody reads the CPER, they know that this was like a intentionally created error, or you can call injected error. So that is the one critical requirement. We want to call that out here. And this is also a very common requirement across all.
I instantly see the usefulness of it. Where is that in CPER though?
If you look at the CPER, I mean the UEFI spec, I can put the link here. If you have it, open it and look into header.
Oh, if I just type CPER, it comes right.
Yeah,
right. I open this so often. So what section am I looking at?
Yeah, in the field flag, there's a miscellaneous.
I'm scrolling up. It's presumably in a common header.
I believe so.
Descriptor or the.
There's a miscellaneous flag toward the end. Section type, ID, section CVD. Maybe you could scroll up, I guess.
Because if we have it, we want it in either the header, or the section descriptor, right? I mean,
yeah, either it is a section descriptor or main header. I don't remember right now, but there is a miscellaneous byte.
I don't recall ever seeing it, so that's why you piqued my interest.
I looked at it and I confirmed with Vilas that the bit is already, I think right here.
Oh, here.
Yeah, hardware error flag simulated. Yep, that's what it is.
And that is this.
Yeah, in a flag. Yeah.
Okay. Yeah, I just had ignored that because it was in a different table and I glossed over it. Very, very good. Okay.
Yeah. So basically, I mean, this is implemented in the CPER, right? But the requirement that we want to put here is that whosoever is implementing this solution, right, error injection and error reporting, should be aware of it and set this bit appropriately, or set an indicator distinguishing injected error versus real error. That's the requirement, right? We don't want to call out like this.
I think, but hold on, like we want to use this flag that's already in secret, right? Uh, but I think this would include spoofing or injection because it
Yeah,
says qualifies an error condition as one that was intentionally caused.
correct.
So,
If you want to distinguish, yeah, if you want to distinguish between spoofing versus real error, sorry, spoofing versus actually implanting the real error, that distinction, I don't think we have it here.
yeah, and I don't think it's as important, honestly. I think,
Yeah.
I think the key thing is, was it intentionally caused or not? I think the CPRO got it right.
Yeah, yeah.
Okay, I like it. That's great. Thank you for observing that. I'm glad you pointed that out. I'm aligned with you on that. That makes perfect sense.
Right.
Okay, I got some feedback. I will incorporate that in, and then you can see the last one is debugging, and debugging is exceptional, right? Debugging is what you do when something really bad has gone wrong and a customer is angry. And so ideally we'd be able to reproduce it and just go off in a corner and fix the problem without involving our customer. But it's been kind of a common experience for me in debugging is that we have, a few thousand machines running this customer's workload, and they're seeing some failure at a rate that seems really unusually high, and we're not sure what's happening. And usually we find some workload strangeness that is uncovering, sometimes it's a hardware fault, sometimes it's a OS bug or firmware bug or a system design bug, but it's really weird. And we end up usually working with the silicon vendor and the customer at the same time to, kind of a three-way discussion to figure out what's wrong. And it's exceptional. We might have a VP agreement between the companies that we can have a quarantine pool and run their tool, like run an instance of their workload on a quarantine pool with debugging enabled in an attempt to reproduce it. But usually that's only the most angry customers, and we're trying to do right by them and help them solve their problem. But it's not. But we have to compromise on security, and the customers don't love that. So we need to find ways to prevent this, but we also we have to get our customers working again. So this is the worst environment to be doing error injection in, but it happens, as Anil pointed out a few months ago.
Yeah, especially more complex failures where there are multiple agents involved, kernel drivers. It becomes pretty hard to narrow down the root cause. So by injecting error and then seeing the behavior and then making some correlation, we can at least say, oh yeah, look, kernel panicked by injecting error, and the D message has a similar messages as we are seeing in the real failure. So let's go chase that, right?
Yeah, and I've also seen cases where the error was occurring, but the software for collecting the error data was written assuming that hardware was working better than it was. So, like a classic example is software that was collecting the error logs assumed main memory was working when main memory was the problem. And so we but the nice thing about those is they tend to be our tools tend to get it wrong, but we tend to be able to reproduce that easily. And so, those are a pain, but we can live with it. Some of them, the hardware just like once a day mysteriously misbehaves. But it's regular enough that the customer is angry, and those are just a nightmare. So I've been in 6-month long debug efforts where there's like daily meetings with our silicon suppliers, and we all wanted to be working on something else, but we had to fix the problem. Okay, well, so I welcome feedback on this table. I don't know if it's what you all intended or not, but this is my first crack at it. So have at it. Please add comments to the document and add questions, and we'll see where things go. And I'll take the feedback that I got today and try to factor that in, to the dot.
All right. Thank you, Drew. Thank you all.
Yeah, thank you. And Jacob, you've heard Anil, so I would strongly encourage you to reach out to him.
Yes, I actually just sent him a message internally.
Awesome. Okay, good. There's a lot we can do, and so, I'd love it if you could help us stretch our thinking towards, how do we look at the broad health of the fleet, and do we have too many no-fault pounds, or do we have fit rates in some area that are higher than expected, and can we work with our suppliers to baseline our failure rates and then catch deviations in those? And so I think that it's kind of like a data center operations view of this, where a lot of us are like R&D hardware view. So I think having the broader picture of it's wonderful.
No, yeah, I'm excited, and obviously, I'm jumping in at a time where you guys are already working on something, so I get it. But yeah, excited to learn and contribute eventually.
Awesome, cool. Well, welcome, and welcome, Manju and Benson. We're glad to have you all here.
Have a good weekend, everyone. Bye now.
Thank you.
Yeah.